helical spring. Now helical spring, we have seen so many things, that is the end connection and all these things. Now we are going to design this helical spring. Let's design this helical spring first. Okay. So how we are going to design it? It's a basic procedure for it. First, we need to find out the maximum spring force which is on which it is going to be act. Okay. And the corresponding required deflection. What type of deflection which want we? In some cases, maximum spring force and stiffness K, which is P by delta. We have to take this ratio. Then after that, we have to select a proper material for it. Okay. So for that, the permissible shear stress is 0.3 times SUT and 0.5 for SUT, or you can use anyone from this. This is based on the theories of failure. Then we are going to assume a suitable spring index. We have seen that the spring index which is more suitable is between 6 to 9. Okay, or you can select whatever you want above the value of 3. So here it is given that 8 to 10, then 8 is considered a good value. Then spring index for spring in values and clutches is 5. So based on this, the spring index we have to select for according to the application. Then yes, calculate the Wahl's factor by following equation. This is K is equal to 4C minus 1 by 4C minus 4 plus 0.615 by C. Now determine the wire diameter, okay, with the help of this term, that is K 8WC by pi d square. Now we need to find out the mean diameter. After that, find out the mean diameter. So determine the number of active coils now, and by using this equation, that is the deflection equation. So this is how we are going to design it. First, we need to find out the stiffness and maximum spring force. Then material selection is there. Take a spring index assumption is there. Then we need to find out the Wahl's factor. Then wire diameter based on this equation. Then determine the coil diameter, and after that, the deflection based equation. We need to find out the number of active coils here. Okay. Then the modulus of rigidity for steel wire is 81370 Newton per meter square. This value we have to put there, and based on that we can find it out. So now decide the style of end. We have seen the style of end for helical tension spring also and for compression spring also. Based on that we have to select it. Then determine the solid length of the spring with the help of following relation, that is NT into D. Okay, number of active coils into small diameter of the wire. So the determine the actual deflection of the spring. Now based on all these equations, the values which we get, we will get a deflection, actual deflection, that is from the previous value you will get somewhat different here. Now assume a gap of 0.5 to 2 mm between the two coils, and the spring is under the action of maximum load. So in tension spring we have seen that there is no gap between the two coils, and in compression we have seen that is a gap between the two coils. The total gap is equal to NT minus 1 into gap between two adjacent coils. Mostly we taken as 15% of the maximum deflection. Then we need to find out the free length of the spring by the following relationship. Okay, free length is equal to solid length plus total gap plus delta. This is how we are going to design it. So based on this, find out the pitch. Pitch is known to us, free length is known to us, solid length is known to us. All dimensions are known to us now, and based on this you can design a spring now. Okay. Then spring rate is there. To find out the spring rate, spring index is already known to us. Find out the proper spring rate, which we have already done in the previous one. Prepare a list of spring specification, and this will end the design procedure. Thank you.